Hi, I'm Natalie and I'm here with Race, and we will be demonstrating the lab properties of solutions of electrolytes and non-electrolytes. Today we'll be using the lab Quest along with the conductivity probe to test these various solutions. So after you turn it on, you plug in the conductivity probe into channel 1. And then when that happens, this will pop up and you'll be ready to use the conductivity probe. Make sure, this is part of the conductivity probe, make sure the range is set for 0 to 20,000. You might not be able to see that well. Here's our data table. The solutions are organized into 3 groups. So here's group A, group B, and group C. Race will begin with group A.
Okay, the reading is 10,087.
Okay, 10,087. Now Race is rinsing the conductivity probe and dry.
The reading is 6,780. Reading is 21,900.
So that is group A. This is group B, starting off with acetic acid.
The reading is 396. The reading is 22,900. The reading is 110.
So that is it for group B. We are now testing group C solutions.
11. $350. $100. And 90.
So these are the group C solutions.
Go.
So the group A compounds were all ionic compounds, which means they completely dissociate in water. So why do they have different conductivity values? The AlCl3 was the highest conductivity value because it produces 1 mole of aluminum, which is has a charge of 3 positive, and 3 moles of chloride ions, which means that it produces 4 moles of ions when it dissociates. In comparison to NaCl, for example, it produces 1 mole of sodium and 1 mole of chloride, which is only 2 moles when it dissociates. The chemicals in group B were all classified as molecular acids. So HCl is considered a strong acid, which means that it completely dissociates in water. So for this reason, the HCl had the highest conductivity value of the acids at 22,900. The other acids are all weak acids, which means that they only partially dissociate in water. So you're going to get less ions, which means a slightly lower conductivity value. The H3BO3, which is our weakest acid, produced the weakest conductivity value of the group. The compounds in group C were all molecular compounds, which means they do not dissociate in water. We tested distilled water and tap water, and our results showed that the tap water had a conductivity of about 350, where distilled water only had about 11. The reason for the difference between these two is that tap water contains ionic impurities, such as magnesium or calcium, whereas in distilled water all of these ionic impurities have been removed. These compounds do not show high conductivity values because they do not dissociate completely in water. Their conductivity values should be relatively zero. For Lab 14, the conductivity of solutions, the effect of concentration, the LabQuest setup is identical to the first. You just plug your conductivity probe into channel 1, and the readout is right here. The only difference is that you need to adjust the range on your conductivity probe from 0 to 20,000 to 0 to 2,000.